Okay, this is recording, so I hope that this thing doesn't screw up. Um, so welcome everyone. This is like a first of the recorded BDK like deep dive into a PR, maybe like a PR discussion club. But today's topic is a PR called CI Move to NIX. And I'm going to do like a brief overview of the motivation behind this PR, what pain points it addresses and how it solves. And once I do that, I'm going to go like more into details on what we are doing under the hood because this is kind of like a big PR. It's changing like it's reducing some underlines and adding a ton of lines. Of course, we are adding some log files here, so those not all of those 5,000 additions they are like relevant, and we are changing 40 files. So first of all, why this PR? So why we are doing this? There are some pain points that we want to address in BDK right now. And the first pain point is that the developer experience is not ideal. So BDK depends on some packages, some system packages like OpenSSL and some other like Mac annoyances stuffs if you're using Mac OS. And also for you to develop with tests and everything, you need to have the Explorer binary and the Bitcoin D binary installed. And also you need to set some environment variables, which um, it is annoying, but an experienced developer can do this. And the instructions vary. If you're using Arch Linux is one thing. If you're using like NIX CI is another thing. Debian, if you're using Windows, good luck. And if you're using macOS is also another thing. And some of these dependencies they are pinned. So Bitcoin D is pinned to a certain version, and also the Electros binary is also pinned to the Explorer fork from Blockstream. So there are some tweaks. And also, we have a minimum supported Rust version, which right now it's 157 or 58. And then you need also to have like two Rust concurrent versions with Rust up. So this is annoying. And third, we also have WASP support. So you need also to have a Rust version with a specific target called WASP32 unknown, which is annoying for you to do this. So, and this is what we do this everything on CI. So on CI, this is easy. We pretty much download the package, download the binaries, set up the environment variables, set up the Rust toolchain, and then we do cargo check, cargo build, cargo test, everything, and then it's fine. But you cannot, it's really hard to run this locally. So this is one pinpoint. The second pinpoint is that there are some annoyances for new contributors. So we do have some commit policies. We require for your commits to be GPG sign, PGP sign, and also we enforce the convention commits um, template. So your commits they have to have like CI, test, feed, fix, prefixes on the commit message, and there is no way for us to enforce this locally. So whenever we have a new contributor and he does some or he or she does something really nice, but he or she doesn't sign the commits or doesn't um, use the convention commits template for the commit messages, then we have to ask he or she to, again, please redo your commits, signing those, and redo the commit messages so this can churn away new contributors, and this is something that we definitely don't want to do. So these are the major pain points. And one thing that we can solve with all of this is using NIX. So what is NIX? In this PR, you see that one of the files that I changed is I created this new NIX markdown file, which pretty much outlines the guidelines and the motivation behind why we are using NIX as our building tool and also for our developer experience both locally and um, on CI. And I'm just gonna go over this. Feel free to. I highly encourage you to go over this. Go over uh, everything on the PR at your own time and pace. But start with this file because this is the whole rationale behind this. And if something is not like very good explain it here, feel free to criticize, to open a comment on the PR, or even so make us a suggestion so that I can fix this. So first of all, NIX is, if you go here, NIX is an operation system and also a package manager. And one of the advantages of NIX is that it has a declarative language that pretty much makes it reproducible and portable. So if you and it supports Windows, Linux, and Mac OS. So if you have a NIX OS derivation, so a set of NIX OS declarative instructions and dependencies on how to build something that is portable across everything. So you can say for your Windows user or your Mac user or Linux user, hey, just run this thing in Nix and it will work. That is not the case with something like, for example, Docker, because when you are building a Docker image, you generally have those steps like sudo apt install, or if you're using like something like Alpine Linux, you have the APK, this and that, and that is time dependent. And for you to pin those things is really annoying and difficult, and you need really to go like out of your way to pin the dependencies in a Docker build. So Docker builds, they are reproducible if you don't need to rebuild the image. If you need to rebuild the image, good luck to getting like a reproducible, a 100% reproducible environment. So Nix can fix this. And there are several resources that are linked here if you are interested in learning Nix. There's also a Nix Bitcoin project. So Nix is being widely adopted over the Bitcoin ecosystem. So we have the Nix Bitcoin project that pretty much helps you like getting a fully reproducible Bitcoin node or Bitcoin deployment. If you want to have a node or something else, you can use the Nix Bitcoin. And also the folks at Fedimint, they have a very, very big like Nix ecosystem as well for deploying their stuff. And uh, I, I highly like not copy, but was inspired by their stuff. And also one of their devs, DPC, helped me a lot in doing this whole migration. And this is why we are using Nix. We want to enhance developer experience and we want to facilitate the onboarding of new contributors. And first of all, BDK has many crates, and you need dependencies to be installed and environment variables to be set. And this can be an annoyance for new contributors, so we want to facilitate that. Also, we need several Rust versions with different compilation targets. So we need like minimum supported Rust version. We also pin our Clippy checks to another Rust version as well. So these versions need to be updated frequently, and we can solve this with Nix so that everything that we are running on CI, you are running if you have like the latest head of the master in your branch, in your local Git repo. Pretty much everything that we run on CI, you can run locally with just one command. And we have the commit styles and commit policies. I also update the contributing a markdown file with to be more clear about those commit policies. And a nice thing is that with Nix, we can enforce those locally. So this PR has a thing called pre-commits, and this has and in the PR we have a developer shell that is on by default. So whenever you do like a CD into the directory, this developer shell will be activated, and then all of the things that you need to do tests or to do anything like the Explorer backend or the Bitcoin D binary, they will be available. And what is nice about this is that it is fully transparent. So it's like an overlay on top of your shell. So all of your like custom shells, if it's Fish, Zeus, or Bash, all of the like your shell configurations, they will be there. We just add on top uh, the Rust binaries that we need with the environment variables and also all of the dependencies binaries pinned to the versions that we use in CR, they'll be added. And a nice thing also is that this shell provides pre-commit checks. So suppose that you are doing like a commit and you don't have, and I'm going to showcase this later, and you don't do like a conventional commit. You commit something like, oh, I fixed this instead of doing fix colon something, which is the convention. Um, this will error and it will give you a helpful error message, and we won't let you do the commit. So it's a check before the commit is done. So it is a pre-commit check. And also, when suppose that you do everything right, when you do like a Git pull, if you don't sign your commits with PGP, which is one of the things that we enforce due to security reasons, then it's going to fail. It won't let you do a Git push. So it will give you a helpful error message saying that you need to sign your commits and won't let you push. So this also helps developers triage new PRs and new contributions because we don't need to check for those things. If a new contributor has done using our NIX environment, we are pretty much sure that everything's done and we don't need to check for those guidelines. Um, Also, has a very rich community. So we have NIX forums, NIX Discord, NIX Matrix channel. There's also NIX Stack Overflow and so on. And you need to install NIX, and once NIX installed, you do all of the PRs, all of the commits that you want to do, and then you need to know if you're gonna have an issue when we are running this in our CI. You just need to run this command here: nix flake -l check keep failed, and or just pretty much a nix flake check. I like the flags because it prints the field build log, so you know what's going on under the hood. If you do a pure Nix flake check, it'll run everything, and your terminal will be like blank. You don't know what's going on. When you do a Nix flake L check, it will print line by line what it's doing. So it's really nice for you to see what's going on in which step of the check Nix flake is right now doing. So this is a nice thing to do. And what we are going to do under the hood with Nix Flake check? What do we check? We check for typos. Yes, typos. This is really nice. We check also if your commits are GP signed and if you're following the conventional commits template. We check for format in Rust code, in Nix code, if you are changing some Nix files. We also do a cargo clip in all workspace using the Rust version that we pin for cargo clip. We also do a cargo format again. We check for dependencies in the security advisory using the Rust security advisory DB. This is a check that we do on our CI, so this can be done locally as well. And we cargo build and cargo test the whole workspace using the latest Rust and the minimum supported Rust version. And we do a cargo build and a cargo check because we cannot run WAS binaries in it's complicated to run like WAS binaries, so just a check is enough. For WAS targets using the latest Rust version, and we do this only on the BDK and the BDK Explorer crates. So these are all of the checks that we do on CI. You can do locally with just one command, and then you are pretty you know that this will pass our CI. This might pass yours and might fail in ours, but in a scenario that you have outdated version of the repository locally. So if you have something like this, you might well rebase and then run rebase to master and then run again, and then if it passes your local environment, will pass our CI environment as well. Um, And what is nice is that all of those checks, they are cached by default by NIX. So NIX, it caches things under a NIX forward slash store directory, depending on your operation system that you have NIX installed. And once you do another NIX flake check, you don't need to wait for everything to compile. So it's going to run the tests, the checks, and it's going to be really fast. So we do this kind of caching. NIX does this caching by default. You don't need to worry about this. Um, and I have some shells that we are providing. And you just do like a Nix develop and the name of the shell like this. So we have a default shell, so we just do like Nix develop dot. And if you want to have like a shell with the minimum supported Rust version, Rust binary, you just do Nix develop dot hashtag MSRV. And also we have the WASM one with WASM compilation support, and all of these dev shells, they handle all of the dependencies and environmental variables. They also do the pre-commit Git hooks that checks either during commit or push events that you are doing those things here, the typos and everything that I just said. And a final note on the dev shells, you can automate this. You don't need to do like Nix develop. If you install Nix dear env in your Nix on top of your Nix installation, you have shell completion enable, and you seamless integrate all of those pre-commit checks even outside of a dev shell. And also you have improved caching of dev shells. So this is kind of in a general overview what this PR promotes. I don't know if we have any questions or comments. This is the general
Actually, I don't.
overview. Yeah.
Yeah, great overview. A quick question. I don't know if you mentioned it, but you said you're installing dependencies. Does that also? I think that's also including the Bitcoin D and ElectRSD, whatever versions we need to run the integration test. Is that right?
Yes.
Perfect. Yeah, that's very helpful.
Yes. Okay, let's dive into the details. So to everyone who's watching, if you're satisfied, you can stop watching now. To everyone that's still watching and wants to know more, so these are the nitty details. So uh, first of all, we pin this dependency. So we are pinning Bitcoin D right now to 0.25.0. So this will change in the future, but we will always be pinning those specifically. And every time that we want to unpin those, update those dependencies, we will do a new PR. So because we don't want to be rug pull under the hood, if Nix packages change those automatically updates those dependencies to like 26 that was launched like I think this week or last week. So we want to those dependencies that we depend on that are critical for our tasks, especially like Bitcoin and Electris. We pin those, and once it is safe for us to update, we are going to update those in a PR. And the main change that we are doing to the BDK like package create workspace is that let me go over here. Uh, we are adding the cargo lock. So I know that we are a library, and we generally, when you create a library on Rust, you do cargo new lib. Uh, the cargo lock is automatically added to the git ignore, but this has changed a couple months ago. Rust changed their policy around cargo lock. So this is the blog post from August 29 of 2023. So right now, cargo new on a library will no longer ignore cargo lock. And there is like all the motivation here, and I also put some codes, some block codes coding there. Um, why they changed this policy here. And for example, Rust Bitcoin, which is a library, they do have a cargo lock committed to their repo, so it's not something that we are like going like uncharted land. There are other Rust Bitcoin libraries that are doing this, and also this. Why do we need this? Because we need this because all of the NIX derivations they need to be deterministic, and you cannot have a deterministic derivation without a cargo lock. So I'm adding a cargo lock and a cargo MSRV lock, which will enhance the reproducibility, and I think it will benefit users in the end because they when they add Bitcoin BDK as a dependency, we pretty much will reduce the number of bugs by having like a moving cargo lock that is not fixed to some file. So this is the big like philosophical change that this PR is bringing to the whole development workflow of the BDK.
Yeah. Can I ask a quick question here?
Yeah.
So does this mean that if a user does a when a user is using this, they should probably avoid cargo update unless they really need it?
Yes, exactly.
Okay. And then what did you mean by a MSRV lock? I'm not familiar with that.
That's not like a concept. It's just that I added this file here. So if you go to files, change it, you see that I have like a I have like a cargo lock and a cargo MSRV lock. It's just that
Oh,
uh
I understand.
yeah,
Yeah. So this was just a copy of the cargo lock for our MSRV, and you'll just swap that in
yes,
and out as needed, right? Got it.
exactly.
Okay. Thanks. That makes sense.
And
Makes sense.
Nix handles this all under the hood. So I'm going to go over the Nix flake in a bit. So Nix handles all of this for us. Um,
And this
so
by doing it this way also. So this is just part of reproducibility. You're going to get exactly the same binaries for the MSRV or for the main version. So that's very valuable.
um,
Actually, sorry,
not
can I ask one question? Maybe you
yeah.
mentioned this already. So in terms of reproducibility, is this actual like binary reproducibility? Like for instance, if we were going to do like a signed binary for some of these for the library, or is that a
Uh,
different thing?
um, it, it is reproducible to the point of Rust reproducibility with the same cargo lock. So, for example, there are some things that might change. So, suppose that you are doing like HTTP that we depend on like UREC or request libraries that under the hood they use like TLS and SSL libraries. So those libraries they will pull different binaries for macOS, Windows, or Linux, and then the resulting binary that is being cached will have a different hash, so it's not the same. However, um, if you abstract that away, we do have the same binary up to a certain like level of abstraction due to like different stuff that Rust is using to compile under the hood depending on our operation system. Does that
Do
answer
you
your
think
question?
like so, well, I guess that does make sense, but I guess the question would still be if I have a Mac and you have a Mac and we both build the binaries using the NIX Flake, will those binaries be the same? Or is there still could be some operating system differences
There
that
still could be some
modify the.
operating systems difference,
Okay,
yes.
okay,
Yes, across
that's
systems,
fine.
yes.
Yeah, okay,
But that would
okay,
be the
yeah.
same
I mean,
thing if I do like a hello world in Rust and I run this in a macOS M1 Apple Silicon and you run this in a Linux I don't know Debian, the binary will be different. So it's the same idea, you know?
okay, okay. I guess you're just guaranteeing that it's built with all the same dependencies at least. So that's
Yes,
it.
Yeah,
It's like we can't say these are like signed hashed binaries. They're going to be
no.
reproducible at this point right now. So okay, that's fine.
And of course, since we are a library, we don't ship binaries. Uh, so that is not an issue for us, I think.
Yeah, actually, the reason I was thinking about this was just because we do ship some binaries with our mobile bindings. So with our Swift and our Kotlin packaging, we do produce binaries. And the way we do it right now is we just find the binaries that are produced by our CI, and we can continue to do that using NIX once we get NIX onto our mobile project. But so this will still help that, just to make it more reproducible. But that's
Yes,
probably what we'll continue to do is just sign it from our CI version, and somebody who wants to run that CI themselves should be able to get the same. Sounds like.
yes. If we merge this, which I think we should, we definitely will, and we have like a good experience, we can also Nixify BDKFFI bindings, and in there I can go into the rabbit hole of like reproducible. We can go into the rabbit hole of reproducible signed binaries.
Right. Okay. Yeah. Don't have to do it for this project, but I mean for the library. But yeah, I think that's down the road something we'll want to investigate. So this is getting us started. That's a good way to yeah step in the right direction. Perfect.
Yes, and I will also have an answer by then because right now I don't know. So, um, let's see. So let me dive into the code, and I can explain what is going on. So let me change screens here. So change windows. Let me go to my terminal here. There we go. Okay, so let me just check if we are in the right one. Yes, we are in the right one. So I'm going to first go over the CI changes. So let's go to the continuous integration. So let me just zoom in a little bit. There we go. So this is our new what we are running under CI. So every time that someone does a push or pull request in any branch of BDK, we are going to run a couple jobs. The first one is a self-care job, which is just a flake self-check. So it's like a self-check of the NIX stuff, if everything is okay, if we don't have like a NIX flake lock that is more than 30 days old, because then we need to update. This is going to fail on CI. Um, but we have an automated CI that updates the flake every week, so it's fine. And then we go to the continuous building integration. This build, tests, and checks everything. This runs on a button on Ubuntu latest. And first we check out the crate, then we install NIX, which is a nice CI action from determinate systems. And then we cache it, or we get cached NIX artifacts. So in a project like BDK, we have like several concurring PRs and concurring commits that needs to be checked. And so having a CI that uses a distributed cache with all batteries included, and you don't need to plug and play, you don't need to configure anything like the match Nix cache action does. It's really nice, and this is also good for forks outside of BDK. So if like user X wants to contribute to BDK and he forks the repo, and now the BDK repo is user X / BDK, this match Nix cache action will work without him having to have access to like API keys and so on. So it's a nice cache action here. Then,
So this was
yeah.
a was this sorry this was a recent change that works with actions then that we talked about before.
Yes, this is something that we talked in our conversations early this week or late last week.
Okay.
that we changed
Go
for
good.
this
So you
one
already
that
put
doesn't
it
need
in.
an API. Yeah, I already did that. And I tested
All right.
on my
Awesome. Nice.
fork and it works.
And this is using the cache within Actions, right? So there's like some storage in GitHub that it's using, or is it still using
Yes.
some other site? Okay, got it. Sorry. Yeah, makes sense.
Yeah, from the overview that
Cool.
I saw in the README and in the code that I browsed a little bit just make sure that I'm not adding something crazy to the CI on BDK. It uses the GitHub cache actions cache machinery for that one.
Okay, that's great. I mean, that's what we've been using. So yeah, I think that should be fine. If we end up needing more storage or whatever, we'll figure that out. But yeah, great to keep it there for now, so we can build it automatically in the CI.
And the nice thing, once I go to show the flake file, which is all the derivations, the depth shells that we are doing, I grouped all of the CI stuff under this CI here thing that I'm highlighting. So everything that we are building is nested inside the CI. So this is a nice thing to organize stuff. So then I do like recommit checks. That's the first thing because I don't want to like do testing and stuff if the pre-commit stuff fails, if you don't have sign committed, if there are typos in your code, or if you don't follow the convention commit guidelines. So pretty much, and if you don't format your code. So pretty much this is the first check that would fail. So that's the first one. Um, and then once I know that this passes, I'm gonna build cache the latest Rust uh, M minimum. I think they should be. Yeah, I always confuse those. Minimum supported Rust version. Yes, I'm gonna do an amend on that change. Yeah, minimum support Rust version. So I cache this one, and then I also cache WAD. So this caches all the dependencies. So whenever you do like a NIX build, or sorry, a cargo build, whenever NIX do a cargo build on those things, the cache is there. And also this allows this guy here, the magic NIX cache action to patch those caches. So if we don't have any changes in the cargo logs for both the latest Rust and the MS minimum supported Rust version, then this part here will pretty much just be a no op, just a check. So this is really nice. Then we run again Rust format. We run Clippy, and this
I'm sorry. I got
Clippy,
to. So
yeah,
I got to. So
go
didn't you
ahead,
already?
please.
I wasn't quite clear why we need to do another. Why we need to do another format if you did it as part of your pre-check? Is there something that could change?
Uh, yeah, I was going over like preparing for this presentation today, and I figured out that we are doing like two Rust format checks, which is redundant. And probably I think I'm going to drop the format in the NIX pre-commit check.
Okay. So you'll do it. You'll do it. Um, well, wouldn't it make sense to do well? So the check is just checking the format, right? I guess.
Yes. So if you go, so let me open the flake here. One second. So we are gonna go over this file in like detail, but if you check where are you? The checks here.
There.
Uh, so we do like a format here, and here we do like extra args here that we don't do that in the pre-checks. Where are the pre-checks? Oh, here they are. Signed commits. Let me try to find the pre-checks. Pre-commit. There you go. These are the pre-commits. So Rust format, we are not doing those custom options. So I'm going to do like a to do here. So I'm going to remove this. There you go.
I see. Okay, sounds good. So you just keep it in one spot.
Yes, and I keep this format here because this one, the one that I do in the CI check, not in the pre-commit, because this one here, it has this extra configuration that we are passing.
Okay. Yeah, definitely like checking the format on the docs too. That's keeps
Yeah.
everything looking nice. Okay, cool.
And then we check Clippy, and Clippy we are using 168. And then we check audit for Rust advisory dependencies like security issues. And I think this is going to be sometimes it's a warning or on depending on the advisory issue could be like an error if it is like a severe security issue. This is gonna error.
Actually, another question. So if any of these steps fail, is there like there's like a fail condition? Will it just stop the CI there?
Yes.
Okay. So if they're doing this, perfect. If they're doing this locally or whatever, they can stop and fix it and then run it again.
Yes. Locally, this would fail as well.
Okay, perfect.
And then we do all of those tests here, which are all of the tests latest, and then we run like all of those. So I group it, all of the latest tests here, like we have CI dot latest, and then we have dot some test. So all it is tests all features latest in the workspace. No default features test all of the no default. No stud BDK test BDK with with no default features and using features no stud. And the same thing for chain and explorer. I just migrate the checks that we are doing on the old CI to the new one. And we do the same thing for MSRV, and we just check the BDK was target compilation. So we check for BDK and we check for Explorer. And this is what we are doing. And I will show this like in detail in the flake.
Sounds good. And just to kind of reiterate what I think you said before, is these nomenclature, the dot, hash, blah, 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 that's something somebody could also manually run themselves if they have,
Yeah.
set up this local, using NIX
Let's
local.
yeah, let's do this. So let's come here. Uh, let's copy this guy. No, not this one. Let me do this one because I know that this one I have cached here. So let's run this here. Let's see what what happens. I know that I cached everything.
I mean, what does keep failed mean?
Means that I want to. Oh, let me grab let me grab my uh, keep. So keep fail means to keep temporary directories of fail builds. So I can easily go
Uh,
inside the result. So let's just this thing run. And then, oh, so this L here thing is pretty much, oops, there we go. This L thing here pretty much like shows all of the commands that Nix is doing under the hood when building that derivation, which is CI, what is it? CI latest all keep fail and keep fail.
oh,
So
that's
when
great.
I'm doing this, I have like let's do a new one here. So oops, let's do ls. So I have a result here. And if I do LL, this result is something that is under my Nix store, something here. So this result will be the result of your latest Nix build call. So whenever you call Nix build
Mm,
something, it will build something under Nix store, and it will soft link towards your result um, folder. And this result folder I added to the git ignore as well, so we don't commit that folder.
perfect. Great. And I assume Nix manages the storage there, so it'll remove old
Yeah,
ones.
yeah.
Okay.
Nix manage the store, and one thing that you can do is you can do like Nix collect garbage delete older than 7 days, 14 days, and this will
Mm,
pretty much do a GC on your whole Nix store. directory. If
Nice.
you are like, oh my God, I run NIX and I'm using NIX for a month doing BDK development, and now my NIX partition is like 20 gigs of size. How do I fix this? You just run this command here.
Okay, but you said it also has its own schedule that it'll garbage collect on its own too?
Yes, and that could be set it up once you install NIX. There's an option. If you do
Okay,
like the NIX install that you are curling a shell file into bash, check the contents, please. But if you do that, there's an option, if I'm not mistaken, if you want to set automatically clean up your NIX storage
okay.
periodically.
That sounds good. Yeah, I just know that sometimes a problem with Rust is that it's yeah, it keeps a lot of data in the dependencies and everything.
Yes, and there's a nice thing that I do. It's called cargo cache. So if you install cargo cache and do cargo cache A, you pretty much will you pretty much will auto clean everything that you're not using. So
Mm,
if your dot cargo or dot cache cargo is too big, you can do cargo cache. It's really nice. It's a package that you can install and it's available in all package managers.
very nice. Yeah, that's great.
So this, as you can see, I did not had like anything already cached because it's been a while since I haven't done like a Nix build in this repository. So pretty much I did this check here. So everything that you see on CI, you can run locally. All of those commands you can run locally, and it'll be the same thing. So this is getting like the latest Rust here, and then it's doing this command here: cargo test release lock it all features. And I'm doing test threads equals true because there's an issue with Bitcoin D that if you pretty much don't if you have a lot of threads, more than 8, it can do like a DDoS on your local Bitcoin D. Oh, then your test fails. So if you do test threads equals 2 or maybe 4, should be safe to do it.
Yeah,
But this was one thing that I had to add.
yeah. I when I test locally, I usually put one, but if two works, that's great. I
Yeah.
I've
For
seen
now,
those
it
issues too.
works both in CI and in
Yeah,
my machine,
as
but
long as it's
I need more people to test it.
okay.
So once
So
this is
this
running,
it's doing building.
yes,
Yeah.
it's checking, it's building stuff. Because it's the first time that I'm doing this. So once this is running, let me go over the flake. Because unfortunately, I have a hard stop in
Hmm.
35 minutes. But we can do
Yep.
more of these sessions as much as we want. I'm fine. So, what is a flake? A flake is pretty much like a recipe to everything that you want to build that uses this source code and other source code. So, a flake has 3 fields: a description, which is optional, but I put the description here, and has inputs and outputs. So inputs is everything that we will be using outside of the BDK repo, Git repo. So here I'm using NIX packages. I'm doing I'm tagging for a stable. So NIX packages, they have 2 annual releases on May and November. So I probably will change this next month once like 23.11 comes around. And this will update all of the dependencies that uses NIX package. These NIX packages. I'm also pinning Bitcoin D to a specific version. And if you follow this link here, you will pretty much see what this is like, how to do this. It's a developer blog and shows how to do this. So I'm pinning NixOS packages to a specific commit hash, and this commit hash is the one that added the 0.25.0 of Bitcoin D. So whenever we want to update Bitcoin D, we just change this ref here to the Nix package commit in NixOS that updates NIX package. So this is what we are pinning. And we're also pinning electrons to Explorer. And I'm using something that was inspired by FedMint CI, but DPC is working on a way to add Explorer, Electros Explorer binary to NIX package. So in the future, this will be handled by NIX package, which is nice. Right now, we are using JKitman NIX package fork, um, which is the same thing that the FedMint guys are doing. And just a note on this thing, because for someone who's watching, oh, but isn't this like sketchy? Not so much, because right now what we are doing is when we are running the tests, our tests in TI, we are running the auto download version on both the electrics and the Bitcoin decrates, and those auto downloads, they download something that was built automatically in those crates by GitHub, and those binaries, they are like 2 years old or something like this. So I think that in terms of security, it is pretty much the same thing.
Yeah, I mean, I think it'll be better when it's in Nix OS, but yeah, seems for now that's a good way to do it, especially if the Fedimint guys are trusting it too. I think that's a reasonable compromise for now. I guess
Yeah,
the
I'm
only thing you would
also
worry about is that if you would potentially be running some random binary, right? That's on GitHub's thing. But like you said, if it as long as they can't like it's fixed to a certain version, would that be right? Like it's not you're not downloading whatever version, you're just downloading a specific one, is that right?
yes, and also so this one is a binary from official NixOS Nix package. This one it builds in your system, so it is not a binary. It's just like instructions to build from this repo
Oh,
here,
okay,
and
okay, okay.
we can go to this repo. So let's copy this and let me change screens a little bit, change windows. Let's go back to this one here. So, and now let's do GitHub. So if we go to the branch add Explorer package and we go to I think we have a flake. So that's what we are building. We are building this flake here. So as you can see,
Mm-hmm.
this flake here, it it pretty much uh, builds. Where are you? Uh, Core system, legacy. Where are the packages?
Well,
But there is a way here that it builds the package here. So this
yeah,
is, it's
that's
probably not in
modified.
this file. Should be in another file.
Yeah.
Default.nix.
Anyway,
It's
I think
probably
it's
this
okay.
file here. Yeah.
I think it's yeah, I think it's okay for now. Just eventually, yeah, well, yeah. I mean, we just don't want if it's if they change something on that repo, then it's going to potentially build something different, and yeah, ultimately, once they get into the next packages, that problem goes away. So I think it's okay to wait for that to happen, and this is fine until that happens.
And these already run. So as you can see,
Okay.
it compiles everything and does the checks. So and then if I do this again, you see that I won't have any compilations. It's gonna run straight to the checks. See, it did everything.
Oh, okay. Okay.
There you go.
That's nice. Yeah. Actually, I had one question. I don't want to derail you too much, but I was wondering if it'd be possible to do the caching checking phase, the like your initial check and your caching, and then have like a separate CI job for you've got like a bunch of test steps in your CI script and your top level script. Like call those commands in separate call them separately somehow just so they can run in parallel so they don't like yeah so at this
Oh
level
yes,
like
I'm gonna
like
do
once you've done
this.
the cache you can make one depend on another like you could just have all of these tests depend on, or these builds and tests depend on previous things?
Uh,
I don't think everything
this
will have to be in parallel, but yeah.
we these are interdependent. They don't depend on one another. So
Okay.
we can run we can run everything in parallel.
Since
It's much easier. And
yeah,
with the caching, this is gonna be
would it
really
be
fast.
faster if you did the caching first and then those caches would be there before you did the rest, or does that matter?
Mm, I don't know. I'll come up with something. But yeah, that's an amazing
Okay.
suggestion. And I'm going to, and of course, make sure that caching is optimal. Let's do it like this.
Perfect. Yep. Sounds good. Yep. I think that'll speed it up a lot,
Yeah.
at least on the
But the
CI side.
yeah. But the main idea here is that everything that you see in CI, you can run locally. Or you can just do a Nix flake check and you run everything if you are lazy to do all of those custom commands. So
Yeah, I think it'll run fast enough locally if you just run them all together. Um, but yeah, on CI it might be nice to parallelize them because it'll automatically, like if one fails, it'll stop all of them. So I think it'll work all right.
yeah, and if we have, since we are a public repo, we have those nice CI machines to run. Let's fry every one of the available cores. I agree.
Yeah. Well, and also they're fairly slow, so we would kind of need to squeeze a little more extra speed out of the one on actions. The local one will go faster, but the actions one would go pretty slow. So need to tune it a little bit better that way.
Yeah. And then we also use Crane, which is a nice building tool for NIX for Rust packages, which has a lot of nice things, and it's really like well maintained. I opened two issues, and one of the issues was really a bug, and so I got like really fast prompt reply from the maintainer. And also Crane is what fatty guys are using under the hood as well. And a lot of things are using Crane. So we won't be getting like rug pull. This is not like something that is unmaintained. So this is pretty much maintained and and I had an amazing experience. And there's like tons of stars also and tons of packages use Crane. We use Rust overlay because it is a very easy way for us to have like different versions of Rust uh, with different components and different target compilation targets. So this has like I think almost 1K stars. It's really well maintained, and a lot of people use this on production. So Fatty guys also use this. A lot of other packages use this. So this is also fine for us to use it. So NumPy is a open source. It's a company that has a lot of open source Nix stuff, and they pretty much are a very good player in the NIX CI ecosystem and industry. So they have like services and so on, and they maintain a lot of like NIX CI open source packages. And so this Flake utils is used like a lot. I think has more than 1K stars. And this is so that we can make like this provide this guy here on line 35. So I don't need to create like a derivation for macOS, Apple Silicon, macOS, Intel, Linux ARM, Linux x86, and so on. This will pretty much like a wrapper that does everything for me. I just do like each default system do this. So it automates a lot of repetitive like tasks that I need to create like a package for every system. So this is what this thing is doing. Advisor DB is the Rust SAC Advisor DB. We use this, so this is an external input. And finally, we have the pre-commit hooks URL. It's from Kashix, another player in the NIX CI industry. And this provides us with our pre-commit hooks, which is really nice. So, and then we have the output. So whatever we use those inputs and we output whatever we are outputting. And so In the output, we have a very big lat block here that there's like a bunch of stuff that I'm going to be using. So overlays, I'm gonna be using Rust overlays. I do some like syntactic sugar here. So to like check if something is Darwin, is Apple. So if it is Apple, I'm gonna use these Apple SDKs because I need those to build. Otherwise, I'm gonna get an error. And this also enhances developer experience and new contributors because they don't need to install anything. They just need to install NIX OS in their Mac system and it will run out of the hood. They don't need to install Brew or anything or do like an Xcode select, install, those kind of things. Um, then we are importing a bunch of packages. The NIX packages Bitcoin D pinned to 0.25, and the NIX packages, which we are using the Explorer from Kitman. And also, I'm writing a shell application here for signed commits. So this is a small shell application that is a package that I'm building on our in the NIX flake. That this checks for verify the signature of the last commit. So this verify if the last commit was signed, and it won't let you push the commit. So this is a Nix pre-commits doesn't have a template, like a already built-in pre-commit to check for signed commits. So I had to build my own. So this thing here. Then we specify all of the Rust toolchains. So this is the latest table. This is the Rust target. Clippy target, we are using Clippy 167. So suppose in the future we want to pin this to 168, it's just changing this line of code here. So it's really easy. Rust MRS, oh my God, minimum supported Rust version is 157. And what is the latest table with targets equals this, so extra targets, and also code coverage we are gonna use with an extension called LLVM tools. So all of this is provided by the Rust overlay by Oxalica. And also we have a nice nightly target that we do nightly on the docs checks, if I'm not mistaken. I don't know, something that we do nightly here. I forgot what
I think it's for
else.
the docs.
Yeah.
For the docs, I'm pretty sure that's where you use it.
So all of those things here, they are handled by the Rust overlay. So the Oxalica one. So this is really nice. Then we pretty much like create like Crane libraries to handle all of those things. So we have for the Rust stable, we had for the Clippy, we have for the minimum support Rust version, WASM, LLVM coverage, and also for the docs. And then we have a bunch of build inputs that we are going to be using. So this is still in the lab block here. So we need Bitcoin D from packages Bitcoin D. We need Explorer from Kitman Explorer. We need OpenSSL, package config, curl, lib icon, and also we need a bunch of lib Darwin that is somewhere here. Down there is, oh, it's up there. I'll show you the lib Darwin. So it's here. This is optional. So we have like Darwin system. We are going to also add this. And then we need also a lot of WASP inputs. So all of those annoying things that you need to install Clang, pin LLVM to something, etc. is handled by these inputs here. So everything's fine. And also we need Python 3 for some dependencies. And this needs to be under the native build inputs. And also if you need some native build inputs for Darwin, we also have like a comment here. So if in the future we need to add, it's here. And then there are like common arguments that we are passing here. So this is the source that we are building. So this is something that we need extra stuff in the source. So for example, Explorer uses Markdown files in the source code to test some stuff. Bitcoin RPC uses DB in the source code. So I'm also including all of the DBs. And also I'm going to also add all of the RS files from Crane. So otherwise this will fail in CI. This is like an annoyance that Crane needs to have. And also, since we don't have metadata in the workspace cargo.toml, I need to set a name and a version. This will not impact in any way like PDKs, create.toml. This is used internally when it's compiling the stuff under like the NIX store. And then I'm setting some environment variables that we need for the CI. So Bitcoin DExec and elect exec, these are when we are running some code that we need Bitcoin D and the electrics binary from the Explorer fork. These environment variables handle this for us. And then I have like common arguments for minimum support works version. So this uses a different cargo lock. And was uses more stuff. So was I need this environment variable. I need to modify the build inputs to add the was inputs. I don't need to do like a check because Crane under the hood tries to run this was binary, resulting binary. So I don't want it to do it. So that's why I do the do check equals false here. And I also have some extra arguments for the build dependencies that I just want to um, cache it and build in the dependency build just BDK for now because all of the crates in the workspace they don't support target was just BDK and Explorer. And then I set a bunch of like annoyances for like compiling, cross-compiling stuff in both macOS and Linux and Windows. So I set those things here, and this takes care of everything. We are gonna definitely use this. What we learned on compiling was once we go ahead and nixify our BDK FFI bindings, and then we pretty much create all of the cargo artifacts that we are like building here. So right now we build the dependencies only, and we cache those as cargo artifacts. And for the regular Rust stable, we just build with the common arguments with um, MSRV. We use the common arguments, and then we do a set. So this double forward slash is a set concatenation in NIX language, and this pretty much uses this arguments here and then concatenates with these arguments here, and this one takes precedence over the last
Precedent.
one. Yes,
Precedent.
precedence.
Yeah.
Yes, precedence over the last one. So if I'm overriding something in the right hand side, this one is going to be used. So this is nice because here in the WASP args, I'm overriding like the build inputs. And this is just so I don't need to type a lot of stuff. So this is really nice. And this is for the Clippy one. So for the Clippy one, I don't have like an argument, and I create a set right here, which is the same thing. And for the format, I'm also doing the same thing. But here I'm inheriting cargo artifacts. So if I want to do like a format again, I don't need to build everything because the build dependencies, they are inherited and they are using across all of the Crane subcommands like Crane cargo, Clippy, Crane cargo format, and Crane build dependencies, so on. And so this is the whole let block. So these are all of the things that I'm specifying as variables that I'm going to use in the output. So these are the outputs. So checks is everything that we're going to check. So whenever you do like a NIX flake check, this is going to run. And you can do like NIX flake show. And as you can see, it prints like a lot of things. And you can see like all of the checks that we are doing. And as you can see, we build checks for all of the default systems. So I'm running this in a macOS M1. So if you see this, So these are all of the checks that I do under the hood. So I do all of those checks, and these are all defined in this check thing. So I use Clippy, I use format, I do the latest, latest all, and all of those is pretty much like doing a cargo test, inheriting the cargo artifacts as a cache dependency in the build apps only. And then I'm running like cargo app test alpha arguments, this one, and and oh, there's a typo here. There you go. And and this is like everything that we are running. So for the BDK test, we do like P BDK. So this one here, BDK, we are doing here. And also for the no stud chain, we are doing P, that's package BDK chain. So we are just testing the BDK chain package. And these are all like one-to-one translations from our old CI to NIX CI. And we are doing the same thing for uh, we are doing the same thing for the MRSV. So let's correct those things here. There you go. And then while we are just doing like a build package, and this was arguments, I don't want to do a check. I just want to do a cargo build and cargo check because the do check will also test it. And to test it, it needs to run the binary. And I cannot do that with was binary. And then we also do the same thing with Explorer. And we have the audits dependencies here. And we do the advisory DB variable that I defined it in the let statement up above. And also I can remove this. I'm gonna do a to do because I need to remove stuff in the documentation as well. And so in our pre-commit checks, I do like hooks on every system here. So this is like a string interpolation. And so every system will have this kind of checks. So I'm gonna run in the whole repo, and the checks is NIX packages format. If someone is like altering like a NIX file, I'm also doing like a Rust format. I'm gonna remove this. I'm also doing typos. I'm also doing convention commits, and I'm doing my signed commits, which is the stuff that I did manually up there in the lab that I create the manual bash script that does this. And
I
then
have
we
a
go to
question about
yeah,
the
go ahead.
typos. Is, is the typo check smart enough? Like we use a lot of things that are not regular words. Will it be able to handle that, or some way to tell it to skip like, or to add to its dictionary? Because I know that I always have to add to my local dictionary in my IDE
Yes, that's an
words that are
amazing
not
question.
normal English words.
So let's do typos. Oh, typos. There you go. Regarding the typos checks, there might be some false positives. In that case, you can add a regex rule to filter out those typos in the typos.toml file. We already included all the false positives
Okay.
we found so far with some expandable comments. So you should be able to do this. So if you go to typos.toml, so right now I pretty much did this like extend, ignore, reject. So this is a base 64 string. Somehow it was flagging in the typos. Commit hashes, SHA, tpub, and addresses, etc. strings. So I did this, and also play2 was also flagging as a typo. People saying,
Hmm.
"Have you mentioned flute?" No, it's not flute. It's play2. So I also added this.
So it must be okay. So it's like, because it's not, because we have a lot of stuff in our documentation that's like Bitcoin specific words, like, I don't know, like block hash or something. It's able to ignore those. Is it just checking comments or something?
It's going over everything.
Or,
Commit
okay. So it
messages,
must be smart enough to find.
yes.
It's what?
Markdown files,
Okay.
Rust
Okay. Well, good to
code.
know.
Yeah.
Okay.
If
Well,
you
yeah, as
go
long as
over,
it has a way to, yeah, as long as this file is there and you've got it in your docs, that's what we need. Then if we do find any false positives, we'll just fix them as we go. So that's great. Yeah, great. You got them.
So if you go to the files change it, you see that even variable names it got. So I have a thing on the example. So let me remove the zoom here. So there is an example here. There you go. This one. So it got it stuff like this. So all of these were like fixes with those things. And also there is like
Ah,
a
okay.
variable name here. Let me try to find it, the variable name. It's maybe here. No. There was something here that so it got like a lot of nice things, but there was like
Yeah.
one example here that was a variable name, and I don't know why. Oh, there you go. See, chain is specific. So this is a variable name, and it corrected.
Wow, that's
Yeah,
incredible.
I
All
mean
right, well
not
we're
corrected.
gonna have very clean code now.
Yeah, it gave me
I mean,
an
it
error,
flagged
and
it.
then I went over and corrected everything.
Wow, that's gonna be great.
Yeah.
I think I even have an issue. I don't know if I'll try to find it. There's an issue I had for fixing all our spelling mistakes. So you're gonna, I'll add it to this issue then because you're doing it. I mean,
Yes,
I'll
I
add
can
to the
add to
PR.
the yeah. I can add to the PR thing that also closes this.
Yeah, perfect.
So finally, these are all the checks. So if you do if you do flake check, it's gonna run everything, everything. And if you do flake L check, it's gonna like keep telling what are the commands that it's doing. So this is really nice. Um, and then finally, the packages is what we are building. Every time that we call NIX build, we call stuff that is inside this package set here in the outputs. So I'm using these legacy packages here because that allows for nested sets because the packages doesn't allow for nested checks. And these legacy packages, it was like old. It is like syntax from NIX packages. It's not that this is legacy and unmaintained in NIX. It's just that this is well maintained, and I took this idea from the Fedmint guys. They also use this. They kind of like abuse the legacy package to have like nested stuff because these I can say, okay, everything that is in CI is inside here. Everything that is in CI, MSRV, I do it here. So I found that this is really nice way to organize the CI checks. So when you do like NIX build, CI, pre-commit, you are calling this thing here. So we are pretty much calling the checks from our outputs pre-commit checks because I don't want to repeat myself. And Clippy, it's gonna run this. And so I define everything on checks and then I call those inside the specific check here. So that's what I'm doing here. The only thing that I'm not calling checks is the code coverage. So the code coverage, I'm calling this, and code coverage, I'm moving away from grcov to LLVM cargo cov, and I have the motivation in the PR. So feel free to read the PR for this, and because there's a nice crane support for this. And grcov doesn't have a good support, and this is also what Pedimint guys are using under the hood as well. So that's why when you go to like continuous integration, you see those things like CI Clippy. So those are the things that I'm calling under the hood, and this is pretty much the same thing if I do like a NIX Flake check. So that's the rationale here. And finally, the dev shells. I'm gonna be real quick right now because I want to have like at least a couple minutes for like questions and comments. So I'm providing the following shells. So default shell. So this shell here will pretty much inherit all of the checks, inherit all of the cargo artifacts from the build depths only. So all of those things, and then it will also give you a bash, git, rip grab, and the rust with the appropriate version and everything set up so that you are developing on the latest Rust that we are using on CI. And also we have a shell hook for the git commit checks, git pre-commit checks for conventional commits and for standard commits. And also I'm setting up all of the environmental variables. M minimum supported Rust version, I'm doing the same thing, but now I'm doing the Rust 157. And I'm also doing the same thing for WASP here. And now we have all of those nasty environmental variables you have available in your shell. And also have a nice shell for lcov and for docs nightly as well, if you want to build the docs nightly. So let me show how this works. So if I do, there you go. As you can see, if I do like nix develop, I think show, no, nix develop show. Is that it? No, but if I do like Nix develop this one here, it's going to pretty much create a dev shell with the latest Rust, and I'm ready to go. So it's evaluating here. I don't know if it's gonna do like some checks. No, it's not gonna do some checks. And now if I do like echo Bitcoin the exact, there you go. If I do echo Electris exact, there you go. I have it. And if I do like cargo V, I have 157. And if I do this with like MSRV, let's hope I don't need to like precompile or pre-build anything. Let's see. Oh yeah, I'm gonna do something. Okay, so while this is doing this, so as you can see, I call without the L flag, so I don't know what's going on here. So I can just cancel this and I can say, okay, Nix develop L this, and now it's going to show what's doing under the hood. So it's grabbing this Rust version and it's pretty much doing a cargo. It's building stuff. So I think we can go over to questions. We have a couple minutes when this is compiling.
Yeah, I think it looks great. I asked all my questions. Yeah, I think this is a huge improvement. So thanks for all this work. It's very, very comprehensive, and I think it's going to be a big improvement to our development process and CI process.
Yeah.
So, but if anybody else has any other questions, I know you have to run, but we can.
I can stay 5 minutes. It's fine.
Okay. I would just encourage anybody else that's listening or watches the video later to comment on the PR. It's 1165 on BDK. So if you're watching this video later, go check out that PR, add comments if it's not already merged. This is something I do want to get in, before we get to our beta release. So this will be kind of our, to make beta testers' job easier too. That's my goal
Yeah.
for when this can be included.
And also we had to do some changes in the Electros and Bitcoin D crates because the default was auto downloading a lot of stuff. And Nix derivations by default, they don't have like internet access. They need to have everything that they have available to build in there. So all of the inputs, all of the packages, they don't allow like auto-fetch stuff from like a Rust crate. That what was happening with the default versions of Electros D and Bitcoin D crates. That's why I had to open those PRs. And I'm doing some changes in
You know,
the Kaggle Toml.
okay. Did Ricard? I saw your changes. They look great. This will also solve another problem that I've been having. The changes you made for ElectRS and Bitcoin D, those test crates, is a lot of our, not a lot, but some of our MSRV pinning was because of the zip and one other dependency, I forgot which one, that came from those crates. But I think with the features you added to those crates, if we just say don't download that stuff, then it won't even include those dependencies.
Yeah.
So I think it's actually going to make our MSRV stuff easier too.
So this is less lines than the currently README on master because I already like documented all of those changes as well once we drop the zip and all of those auto download stuff
Okay.
from Bitcoin DM. Yeah, that is already done
Yeah,
there.
I've started looking at potentially upgrading our MSRV to 1.63, which also gets rid of most of the pinning. So I'm keeping my fingers crossed we'll be able to get that in also, the bump in MSRV. We'll see. We're waiting just to find out if all our users are okay with it.
Yeah, and we can wait for the next PR to on that decision because then I can like I can like do the changes for 163 MSRV, and then we don't need to like redo another NIX CI like PR 1 week after we
Yeah.
merge this
Okay.
one.
Yeah. Okay. That sounds like a good idea.
So this is kind of building, but the idea here is that is gonna give me a shell with Rust minimum supported, Rust version with everything okay, and then I can do like a cargo test, and I'll be cargo testing my Rust. I'll be cargo testing my Rust MSRV. Actually, I just realized that I need to do one thing here.
And just like
So
you showed before, this will all be what you're building now will be cached, right? The downloads of the dependencies,
yes,
the download build. So it'll go faster next time.
yes, as you saw, like if I do like a Nix developed this, it's automatically. So let's see, it's just gonna do a check and come on. Just because I said it's gonna be automatically, will it be like naughty and do like a bunch of compilations? But I think this is gonna be automatic. The problem is that um,
Is it
if you
something
check,
locked because you're in the other shell?
no, it's because I'm compiling and like my CPU usage is like all over the roof right now. So
Right.
that's why it
We'll just
needs to
max out your
like
system.
evaluate if something, there you go. It's just gonna build one thing, but it's gonna like go, there you go. So since these are run already,
Okay.
the next time
Yeah.
is instantaneous. Whereas the MRC, MSRV, I haven't run yet and it's like compiling everything. But if I do again, I won't have to
Yeah.
wait
Yeah. Yeah.
all of those things. So
Perfect.
I need to do like a cargo lock and var to point to cargo and mastery lock. That's the only thing that I need to do in that shell that I forgot right now.
Oh, okay. Okay.
Yeah. But that's like the overview of the PR. I know that we are introducing
That's
like
great.
NIX and it's a new language. It's awkward. It's kind of like there's a new things to learn. I give like an overview of the flake, showing up like how um, showing up like what is the logic behind all of those commands, but I don't explain the syntax directly. So yeah, that is one thing that we cannot cover today, and probably we won't be able to cover uh, in just one session.
Yeah, I think the main concern people might have is just that NIX is a big new language to kind of learn. If they want to maintain the CI, it's a lot of new things to learn. So, but I think now is a good time to bite the bullet and do it. So I'm very supportive of all this, and it is kind of in line with some other Rust projects. I mean, some other Rust and Bitcoin projects. So I think we're in good company there, and hopefully can get help from them if we get stuck on something, and then eventually be able to help them also. Like just have our project collaborate. I think that's great. Um, Having the new development environments for new developers will be a great thing to have going forward, and especially as we expect to get more contributors in the future. So yeah, it's all great, and I really appreciate all the documentation you did on this too. This will be really helpful so that all the maintenance doesn't fall on you for this. That we can all pitch in as needed.
Yeah, and I put some like issues in the PR, also in the PR text, saying like, okay, what are the problems? Oh, we are like the BDK CI bus factor is pretty much like two right now, maybe myself and another developer. But there are some like, I do disclose those issues in the PR and it's open for everyone to argument, check, counter argument, and so on.
Yeah, that's great. All right. Well, thanks for doing this. We'll, like I said, make this video available somehow to the folks who weren't able to join. And again, just a reminder to comment on the PR if you have questions or comments for Jose. And we'll, hopefully get this in shortly.
Thank you, folks. Bye bye.